All right, we're going to finish up chapter 3, looking at some real-world applications of where we can use all these exponential functions and logarithmic equations to be able to calculate how much money we can possibly save, or also how much money we are going to owe if we borrow it from someone. So we're going to be looking at different interest account of putting money into a bank account, collecting interest. We're also going to be looking at annuities, which what I mean here is talking about future value. So if you are going to invest some money into a mutual fund or some sort of fund that's going to collect you interest over time, and something for like retirement, that's what an annuity is. And then you have loans and mortgages, which we're going to be talking about present value. So if you go and you buy a new car, you're looking at how much that car costs you initially, and we can figure out how much your loan payment, your payments would need to be each and every month. Same thing with a home and looking at the mortgage of a house. The first three formulas that we look at are going to look familiar from Algebra 1 and Algebra 2 because we've talked about them there. And this one actually even looks familiar from earlier in this chapter because it's our exponential growth model. When we're taking an initial value here, multiplying it by a growth rate that or growth factor that's greater than 1 and taking it to a power because we're working with that repeated multiplication. So what's happening here is that P value right here, this is your principal. That's how much we're starting with. The R is the interest rate, and our N is representing how long the money is going to stay in the account for. So here we have Lane who wants to invest $500 at 7%. And he's going to leave that money in there for 10 years. So what we can do here is we can calculate how much he's going to end up having, or what that $500 actually turns into after 10 years. So if I take 500 and I multiply it by 1.07, take that then to the power of 10. And he now, that $500 was now turned into $983.58. And that's working with an annual interest rate where it's being added on every once per year. Now we can also have interest that is being broken up and multiplied throughout the course of a year. So what's happening here is we're taking 9% annual interest, so 9% overall, but it's going to be compounded monthly. So we're going to be breaking this 9% up and taking a portion of it each and every month. And so here we use a different formula where we're taking again the principal amount of how much money is you're starting with. It's going to be invested at a interest rate, and here we have 9%. And this K value is representing how many times is it being compounded. And the fact that it's being compounded monthly here, our value of K is going to end up equaling 12. If it said that it was compounded annually, K would equal 1. Semi-annually, 2. Quarterly, 4. Monthly, 12. Or daily, 365. And I'm going to put that K into two separate spots. And then finally, we have the T value here, which is the amount of time that the money is going to sit in the account for. So we're going to take, sorry, I have to pause this. I got to take this phone call. Okay, so now we've got our principal amount, so that's going to give us 500 times the quantity of 1 plus 0.09 divided by 12, since we're compounding this monthly, and take it to the power of 12 times 5, since we're looking at 5 years. Now, as we start putting all this into our calculator, just be very careful. One of the biggest mistakes is once you get to the exponent part of this, you can do it, break it up into parts if you'd like to. But here we've got 500, and we're going to multiply it by a quantity of 1 plus 0.09 divided by 12. Make sure we close up that parenthesis, and now take it to the power of, and some of your calculators go ahead and do the exponent for you and keep it up there. Others of you, you're going to have to make sure you use parentheses here to take 12 times 5, because you want the 5 to be part of the exponent. You do not want that to come down and multiply your answer by 5. So hitting enter here, and we end up with $782.84. The next one is looking at the same type of formula, but this time looking at figuring out how long would it take for an investment to grow to a certain amount. So we have the initial starting amount, the principal amount. We've got the interest rate at 9%. It says it's being compounded quarterly, so that tells us that K is going to equal 4. And it's asking us how long will it take for our investment to reach $3,000. Well, that's going to be our value of A. Ultimately, what we are solving for is we are solving for how long will it take, so we're looking for how many years. So as I plug everything in here, I'm going to get 3,000 is equal to 500 times 1 plus 0.09 divided by 4 to the power of 4t. Now what we have here is we have an exponential function that we're solving for our variable that's up here in our exponent. So we're going to have to use logarithms to solve that. In doing so, what we need to first of all get rid of, so that we don't have to use all of our properties of logarithms, is we need to go ahead and divide both sides here by 500. This is going to make it a lot easier for you down the road, and we don't have to do as many steps. So 3,000 divided by 500 gives me 6. So this is going to be equal to 1 plus 0.09 divided by 4 to the power of 4t. Now that I have my power all by itself, here's where we're going to take the logarithm of both sides. And this allows for my exponent to come down and out in front. So I have the log of 6 is equal to 4t times the logarithm of 1 plus 0.09 divided by 4. And there we are. And now we're going to solve for t. And to solve for t, I'm going to divide everything here by 4 times the logarithm of 1 plus 0.09 divided by 4, both sides. Now once we start putting this into our calculator, the one key thing about working with all of these problems is that you do not want to ever round off anything in the middle, because round off error is going to end up changing our answer immensely, especially when you start working with large values. So going to a calculator here and solving for t now, I'm going to be taking the log of 6, close that parenthesis, and now I'm going to divide it by the entire quantity. So I'm going to use an open parenthesis, and here's where I'm going to put that 4 in. And then I can hit log. It opens up another parenthesis to do 1 plus 0.09 divided by 4. Close the parenthesis and close the parenthesis again to close out what's going to be in your denominator. And so when I hit enter here, I get 20.13. So it's going to take approximately 20 years for this $500 to become $3,000 at that rate, being compounded quarterly. Now the next one talks about going into interest. Sorry, this is interest up here. That's being compounded continuously. What that means is that you are constantly, every second, every half of a second, you're getting interest that's being added onto your account. That's being compounded continuously. So when we talk about the formula we just did and we say, okay, everything's being compounded daily, we'd have K is equal to 365. Well, if it was hourly, that K value would be even larger. If it was every minute, it'd be even larger. If it was every second, every half of a second, the number of times that it's being compounded would increase immensely. Well, as K goes to infinity then, what ends up happening here, actually k goes to infinity, of 1 plus r over k to the power of k, what we end up with here is k gets really big, you end up with e to the power of r. So whatever that interest rate is, as k gets really big, that e, that 2.73 to the power of our interest rate, ends up coming from that limit. And this is where our PERT formula comes into play. And this is dealing with if a account is being compounded continuously. The key word here is you need to have the word continuously added into here. If it said compounded annually, we're going to go back to 1 plus r. Here we're working with a compounded continuously. So we're going to use our PERT formula. We've got our principal amount of $100. We have an interest rate at 8%, and we're going to keep it in that bank account for 20 years. So here A is equal to 100 times e to the power of 0.08 times 20. Going to the calculator. Take 100 times e, so I'm going to hit second and the division sign. Second first, then divide. And then we're going to go to the power of. And here you're going to again want to make sure that you're using parentheses, especially if you have the older graphing calculators, because you want to make sure the 0.08 times 20 is in that exponent there. Hitting enter, and we end up with $495.30. Now we can take this problem here and, we could figure out, well, how long would it take for this $100 investment to reach $1,000? And that's something then we can use logarithms to help us find out what that value is for t. So these four, again, these three should look familiar to you. You've seen them before. And now we're going to get into the two formulas which you have not seen before. And these formulas I'm not requiring you to memorize because they are very complex, but we do have to be aware of what all the variables are going to represent in the problem. So here we're going to take a look at annuities, which is talking about the future value of something. So if you are going to invest money, how much is going to be there after a given amount of time? And that's our future value. What's going to happen in the future to it? So in this formula here, we have a couple different variables. First of all, R, which is the dollars invested of how much money is going to be going in, starting at. Then I, this is not the imaginary unit of I. This is representing the interest rate per compounding period. So what this is doing here is if you were going to have something in an account that's going to be at 10% and it's going to be compounded quarterly, we would have to take that interest rate and divide it by 4. And then N is the number of equal periodic payments. This is how many payments that are going to be made. And if we're going to base this off of being compounded quarterly, and say it was going to be 10 years, we would take 4 times 10 to end up getting 40. So I'll go through an example of working with an annuity here. And if at any point you have questions, just make sure that you're jotting them down. So here at the end of each quarter year, Emily makes a $500 payment into a mutual fund. So right there, it says at the end of each quarter year. Okay, so that means every 3 months, Emily is making a $500 payment into a mutual fund. Her investments earn 7.88% annual interest compounded quarterly. What will be the value of Emily's annuity in 20 years? So it's telling us how much money she's starting with. So we're starting with the $500. For this value of I, what we're going to be doing here is we're going to take that 7.8%, so 0.0788, and because it's being compounded quarterly, I have to divide it by 4. And then how many payments she's actually going to make over 20 years. Since she's making a payment every quarter, she's making 4 payments a year for 20 years, which ends up telling us that we're going to be making 80 payments over the period of 20 years. So now if I go ahead and plug everything in to figure out what the future value of her mutual fund is going to be, we're going to take 500 times 1 plus 0.0788 divided by 4. Take that to the power of 80, and then we're going to take all of that and subtract 1 from it. And we'll take that entire quantity and we'll divide it by 0.0788 divided by 4. Again, the hard part about this problem is going to be putting it into your calculator and trying not to miss a really important step to it. So in order to not miss anything, what I'm going to do is I'm going to break it up into steps. I'm going to start on the numerator here inside the parentheses, and I'm going to take 1 plus 0.0788, divide that by 4, and I'm going to take the answer right away. Now I'm not going to round it at all, but right away I'm going to go ahead and take that to the power of 80. I'm not going to round this answer at all either, and I'm going to subtract 1 from that answer. And all I'm doing here is just order of operations. Now I can go ahead and divide by, and here I'm going to have to use parentheses. I can divide by 0.0788 divided by 4, because I want to divide by that fraction. Hit enter. And then finally I can multiply that answer times 500. And this is going to end up giving us what our future value of the account is, which that $500 turned into, where's mine, to $95,483.39. So not a bad investment here if you're going to take $500 and leave it in there for 20 years and all of a sudden you have $95,000. So that's how the future value works. The next example that I'm going to go through is a loan example. So it's a different formula looking for the present value in something. So if you were to have payments of a certain amount for a car or for a home, we can figure out what the actual present value is going to be. What is the cost of it currently? So here you have R, which is going to be your dollars earning, which is actually here. This is going to be your, I should say more like your payment. I like that idea better since you're working with a loan. So it's going to be your, sorry, I'm just looking at something. Okay, so that's going to be your monthly payments of what we're going to be working with. I is the interest rate per period. So here again, if you are having an interest rate that's being that's happening every single month because you're doing a monthly payment, then we need to divide it by 12. And then N is representing how many payments that are actually going to take place. So the example that I have for us to look at is with a car purchase. So Carlos purchases a pickup truck for $18,500. It says, what are the monthly payments for a 4-year loan with a $2,000 down payment if the annual interest rate, which sometimes you'll see as the APR, is 2.9%. Well, what's happening here is we're actually trying to figure out what the actually payment is going to be. We know the present value of the truck. And our present value of our truck is starting out at the $18,500. Now, he does make a initial payment of $2,000, which now takes the price of our car down to $16,500. So he wants a loan for that amount. Our value of I that's going to be used here, we're going to take this 2.9% and we're going to be dividing this by 12 because this interest is going to be added on every month since you're making monthly payments over a course of a year. So we're going to have to add the interest on every month. and how many payments we're going to be making. Since there are 12 months in a year and he's going to be doing a 4-year loan, then we're going to be taking 12 times 4, so that's going to give us 48 payments that are going to be made over this period of time. So in this particular problem here, we want to figure out what his payments are going to be. So we're actually solving for R. We know that the present value of the truck is $16,500. And so then I've got that equal to R, and then I have 1 minus 1 plus, and 0.029 divided by 12 to the power of negative 48. And then we're going to take all of that and divide it by the 0.029 divided by 12 as well. So solving for R, really what we need to do here is simplify everything that we currently have right here. Because then eventually here we can take the 16,500, we can divide it by what I have shaded here in the yellow, and that's going to give us our monthly payment. So I'm going to go to the calculator, and I'm going to figure out what that amount is inside the parentheses. So starting out with 1 minus, and I'm going to open parenthesis of 1 plus 0.029. Take that answer divided by 12. And then I need to close the parenthesis and take that to the power of negative 48. And I'm going to go ahead and hit enter at this point. And now I'm going to take that answer divided by our denominator of 0.029 divided by 12. Hit enter as well. And so now here I have $16,500 equals R times that amount that I have. To solve for R, what I'm going to do is take that 16,500 and I'm going to divide it by the previous answer. I do not want to round the answer at all. I want the calculator to take that value, because then it's going to actually give me my monthly payments. And here I end up with a monthly payment of $364.49. And so now that we've gone through all these formulas, the present value and future value formulas, they're very complex, but they are used everywhere. Every month, I'm sure that your parents get bills that are in the mail, whether it's credit card bills, it's a mortgage payment, car loans, whatever it may be. Usually you have to take a loan out at some point in your life to be able to pay for something. And so here, this is how those amounts are actually being calculated. When you look at these, we'll be practicing these problems in class, but if you have questions of where these formulas are being coming from, make sure that you let me know. I know that this video was a little longer than usual, but that's all right. We can handle it. So I guess that's about it. So we'll just see you in class.